Hello, everyone. So, what are the issues involved in this case that should be considered in order to design this study, and what are the concerns here? This is the main question for this study. We have seen that Dr. Uno proposed a randomized controlled trial to solve, and actually this randomized controlled trial is not feasible in this situation, even if it can have a strong internal validity and also eliminating confoundings. But this case scenario is not fit for an RCT because not ethical to assign patients to an RCT, first of all, and secondly, the treatment itself is based on the doctor preferences, so we don't have like a standardized treatment model. Actually, a randomized controlled trial is not that good in here. Since we have a huge database, we might want to use it and to do a retrospective observational study, case control study. But since we want to create a change in the system, we have to make sure that the results that we get from this case control are reliable and valid, not that they are. In order to do so, we need to control for different points in our study, and the most important one is confounders. If observational study is really a good option for this scenario, but we need to really create our group and to understand their baseline characteristics, such as confounders that can influence the outcome. And based on the baseline characteristics, we can search to find others matched, to find pairs. And then we can get the scores from them, and then we can compare and see if the treatment or if the interventions actually has an effect on the people or not. So propensity scores actually is a good option from my point of view. We have 4 models. We have matching, we have stratification, we have covariate adjustments, and then we have weighting by propensity scores. And I believe the matching is the most used, and it's simple, it's intuitive. But after we've seen the baseline characteristics of our patients or of our exposed group, like after we see the confounders that can affect the outcome, we have to search for people who share the same baseline characteristics as them, and then we have to compare them. This is not an easy task, since in the matching process, as Andrea already observed, we might lose a lot of patients, which can affect our internal validity, and maybe our results will not be so statistically sound. So an option that I propose, and to answer Andrea's question, is that maybe we can use matching with replacement, which is the same comparator can be matched for different subjects, and then we can replace the same, even the exposure, we can replace them, and then we can match and replace in different ways, and then no one will get lost because we create some kind of a pattern. Then we can also have full matching, like one to many or many to many, which increase flexibility and also can reduce data loss, so we can have a bigger sample. Another option would be using inverse weight probability in order to keep our sample size and not lost data. It's pretty straightforward, and we can keep all the patients inside and adjust for their contribution to the estimate. After we matched in different ways based on the researcher option, we can combine with regression, and we can apply regression on matched pairs to regain power and to be sure that our data is clean and there is no unnoticeable confounders, so our results are not biased. There can actually infer causality. However, I want to say that we can adjust results with careful consideration will make our study not only a powerful study that infers causality, but also can keep safetiness after all.